Hi everyone. We are going to continue our discussion on the graph algorithms, and as you can see, today's title we are going to do topological sorting and the minimum spanning tree. Okay, so a very quick review about the depth first search. So for the depth first search, and uh, we have another running time of the O V plus E searching algorithm, and uh, remember when we are talking about detecting the circles, well, we can do that for either the directed graph or the undirected graph. So we can detect the circles in both types of the graphs. And a for a circle, it could be like, say, let me draw a very small graph here. Say if we have 1, 2, 3, and 4 nodes. If we do this, and then well, this graph so far is fine, right? Because there's no circle that we can go back to another node. Well, if I add this edge, and in this case, well, we have a circle, and then we can run the DFS to detect the circles. And the rule is, well, when we are doing the DFS, the original algorithm only want to visit the new white nodes. But at the same time, when you see a adjacent green node, and then when you see there is a adjacent green node, and then you have already found a circle. So if you only want to say is there a circle or not in this graph, and then as long as you see there is a adjacent green node, and you can immediately return a true saying I have already found a circle, right? And we can actually determine whether if we have the circles in a OV time. And the reason is if we are having a undirected a cyclic forest, and then the number of the v should smaller than the number of the e should be smaller than the number of the v minus 1. And if we have more than that, if our e is higher than that, and then it is guaranteed we will have a circle. So for this case, okay, if you see this one, we have 4 edges, right? And then we have 4 v. Okay, so in this case, and then we do have a circle. And well, the next question is, well, can we simply compare the number of the edges and the number of the nodes to detect whether we have circles or not? So in this case, well, we have the four edges and the 4 nodes, and then, well, this violates the rule, and then we say there is indeed a circle, and that works, right? Well, but in another case, can we always just using the number of the edges and the number of the vertices to answer this question? The answer is no. So let me give you another example. So I'm gonna, okay, we have a total of 5 nodes, and then we only have 3 edges. Okay, so 5 nodes, 3 edges. So this edge is a 3, right? And then this v is a 5. So 5 minus 1 and 3 smaller than 5 minus 1, it is true. So in this case, if we simply do the counting of the edges and the number of the nodes, and then we find, okay, 4 is smaller or equal to 3 is smaller or equal to 4. And in this case, it doesn't violate the rule. However, we do have a circle detected in this graph. Okay, I guess my wife is calling me and I have to pause my video here.